So, quick question for the crowd. How many people in here are experimenting with AI ML now, whether personally or for your day job? That's it, really? How many people in here have played with ChatGPT? Okay, so you've all experimented. Okay, so with that, I think saying going forward, by and large, AI ML is going to be one of the key drivers of business value for customers and businesses going forward. It's already changing what customers expect of us to deliver to them. It's changing what's expected in our products. It's changing what's expected of support. It's changing how we do business. So if you're not already thinking about how you're going to take advantage of analytics and all the data your company's been collecting, you should probably start thinking about it, right? And look, this isn't all new stuff, right? There have been a lot of use cases around for a long time when it comes to analytics. Not everything is generative AI. Don't get me wrong, like the creation of ChatGPT and Bing and Bard has really accelerated the amount of interest that comes to AI ML. But these algorithms, they've been around since the 60s. And companies for a long time have been collecting data, but now with the combination of compute and storage and accelerators being generally available, it really gives you the ability to take advantage of that data and change the way you're doing business. And if you're just getting started, Red Hat, we've been thinking about this for a long, long time. I've been doing this for over 20 years, so I've at least 20 years worth of experience looking into this stuff. There are a lot of challenges that you'll encounter along the way that we've already thought of and we can help you work through, right? By and large, most companies today, if you have a data science team, they're pretty good at developing a model, right? Most companies, you could put some data in, run an algorithm, you're going to get a model out. Whether or not that model's accurate or not, like that's a different story, but most of the time the development aspect is pretty easy. Where companies are largely struggling today is to take that model and put it into production. And so this survey we did a little bit last year, and we redid it this year. The thing on here that stands out to me is that over 50% of companies today can still take 7 to 12 months to take a model and put it into production. That's one model, right? The one model that you can probably develop in maybe a week, right? Maybe even a couple hours, you could build a model. If you were to hand that to your operations team and application team and ask them to put that into production, it would take 7 to 12 months. 7 to 12 months. Like, babies walk in less time than that, right? So you can imagine, like, at the pace at which AI ML is advancing, if it takes you 7 to 12 months to put something into production, you're falling behind, right? Your competitors are going to outpace you. You're not going to remain relevant in this space. Like, that is the area that you have to put a lot of focus on. You know, especially now with what's happening around generative AI, AI was always moving fast. There was always something new coming out. And I used to give this talk 6 years ago, a similar talk, not the same one, so it's not been reused, don't worry. But I used to say, like, every 6 months there's a new framework coming out for AI ML. And that was about what it would be. Every 6 months there was a Cafe 2 or a PyTorch or a TensorFlow. Like, those things were advancing. Now it's weekly. Weekly, there's a new model coming out. Weekly, there's a new framework coming out. There's a new accelerator, a new library, a new technique. 7 to 12 months is a lifetime if that's how long it takes for you to take advantage of those things. And there's more complexity than just that, right? That's just the model side of things. And like, I know Israel has a lot of startups, so how many people in here are in startups? Just a few. So if you're in a startup, you get to start from scratch. So like this next part, maybe not so applicable. But a lot of enterprises, they have a lot of infrastructure, technology, components, people, and processes already in place. So it's not like you get to start from scratch and say, hey, I'm going to build a model, and I'm going to throw that into a brand new application, and life is great, right? When we talk to customers, they have a lot of pressures. They're already worried about infrastructure, how they're migrating existing infrastructure over to new platforms. How are they going to adopt the cloud? When they're looking at that, they're also looking at application development. So net new development, they're trying to take advantage of new technologies like containerization and new frameworks, but they have legacy applications that they're worried about migrating over. So there's a lot of pressure on the infrastructure side. When we look at applications, right, there's a lot that goes into application development. There's still a lot of monolithic applications that we're breaking down into microservices. You're trying to migrate those over to serverless and newer technologies that can help you scale and better take advantage of economies and finances. And then there's the people aspect, right? We have teams that have to support these things while they're trying to learn to adopt a new CI/CD process and integrate AI/ML into these applications. So at the end of the day, like, customers already have enough to worry about when it comes to how are they going to maintain their infrastructure going forward, how are they going to stay competitive with the applications they already have, and how are they going to maintain a set of platform capabilities that's attractive to bring new talent into the organization, right? Because that's what we need. We want new talent to be able to take advantage of this. And so one of the key areas, though, is how do we embed AI/ML in this, right? That's a pretty complex landscape to worry about. And the good news is, again, like, we're going to talk a little bit about what it takes to put this in. AI/ML, it sounds like a very simple thing, but if you look at a general ML system, the model itself is a very small portion of the entire system, right? It's a very key portion, but in order for you to have good analytics, you need good data, right? And just like we've been doing with applications for the last 10, 20 years, you need an operational lifecycle to support that. So you have to have components that actually support the testing, validation, lifecycle, monitoring, integration. All of those things that you're doing for applications, you have to worry about for models as well. And some of the considerations there are unique, right? When you have an application, you put it out there, you're able to monitor it, and generally it behaves the way we're looking for. Data might change, or users might interact, or maybe somebody tries to bring it down. When it comes to models, very sensitive to the data that comes in. And so if patterns start to change, or if data comes in that it's never seen before, your model might be producing bad recommendations back to your users. So how are you going to lifecycle that quickly so that you're not potentially, harming your reputation with customers? If you're doing next best recommendation or discount recommendation, how do you make sure you don't give away your business because you're giving out bad data? So there's a lot to be concerned with here. All right. And so in the end, your success with AI/ML is going to rely on the repeatability of your processes. And not just repeatability, but the transparency, auditability, and overall governance of those processes as well. When it comes to AI/ML, we put a lot of trust into that little computer machine service that's going to tell us what to do. And in order to have that trust, we want to know why it's making the decision it's making, how it was trained to make that decision. And in some cases, this is mandated from a government perspective and from an overall regulatory perspective. So just like we do with DevOps, where you have code validation, code tracking, code changes, all the things so you know if a bug made it into your code, how to get in there, when did it get introduced, how do I change, roll it back. You want to apply that same methodology when it comes to models. Right? What data was used to train the model? What data was used to validate the model? If you're iterating over multiple models, what changes did you make in your model code, and how was that reflected in the recommendations it made? All of that will lead to overall confidence in these models at the end of the day. All right. And so all those stages, they probably look pretty familiar, right? MLOps, DevOps, pretty similar stuff, right? The two just come together. There are some distinct challenges, though, when it does come to models. So on the training and serving side, workload management is a critical one, right? How are we going to, when you look at different models, they require different compute environments, right? Some require GPU accelerators, some can work fine on CPUs. So you want to make sure in the training environment, you're optimizing for whatever your use case is. You don't want to give all of your developers 28 GPUs. That's a pretty expensive proposition, right? So workload management becomes pretty critical. This thing works too. Okay. Orchestration is the next one. So how are you scheduling them? So even if you're able to say that, hey, a particular job needs CPU, you want to make sure from a scheduling perspective that that is actually happening, right? That you have effective scheduling, that you're reclaiming resources, and you're maximizing all the throughput on the systems you have. That also means, again, like some of the infrastructure that it takes to build models, train models, it's pretty expensive, right? GPUs aren't cheap. So we want the ability then to be able to explode and take advantage of cloud resources. If we run out of private data center resources, it's nice to be able to do a very large training job in the cloud and then bring that model back and maybe deploy it on-prem or on the edge, right? That's a very common use case. Next is platform complexity. So this is one where we have thought ahead a lot, where traditionally, even 6 years ago, a lot of customers I talked to were building models, and they were serving them on the same platform they were building them, right? So they had a large cluster. That cluster served their application platform as well. So they might build a model, and then they'd stand it up as a service for applications to integrate with. So there wasn't a lot of platform complexity at that point in time. But now with the explosion we're seeing around edge deployments, you might train your model on a centralized cluster platform, but you're going to deploy it to specialized hardware at the edge. And there's a lot of complexity that goes into optimizing models for these types of specialized hardware environments. So you're going to want some level of isolation and consistency in the environment you're rolling out to. And I see a lot of folks like, oh, that's scary. It is scary. Like, these are things really you have to be worried about because, again, the challenge is not putting out the first model. Like, that's great. It's a fantastic feeling, the first one you get out there. But when you start thinking about managing hundreds and thousands of models across thousands of nodes, that scalability problem is where you're going to really care about these things. And that's the last one here, fleet management. It's not becoming uncommon now. There used to be a nice one-to-one relationship, right? I'd build one model, I'd stand up one service, and then I would scale that service, and then my applications would all call into that service, right? Pretty common use case. Now, again, with a lot of the edge deployments, what we're seeing is that one model might be deployed across 4, 5, 10,000 nodes in a factory floor somewhere. So if I'm doing monitoring of like sensors on a factory floor or an assembly line, that one model might have to be managed across multiple factory machines, as well as multiple factories. So you might have variants of existing models. So there are different humidity challenges based on elevation. So you might have the same general model with different variants. That overall fleet management is something you want to think about ahead of time. And then we talk about lifecycle. So again, that's just to get the first one out, right? Like, this is now about getting the next few out. So that rollout coordination, right? There can be a lot of friction between the ops teams, data science teams, and applications teams. For those that have played around with data science, how many of your data science teams have ever just like chucked the model over the wall to the app team and said, here you go, like, good luck with it, right? It's a couple people, right? It's very common, very, very common. A lot of what we have focused on is connecting these personas in communities, right? So if you've been with Red Hat for a while or if you've played with our tools, you know that like our history is in operating systems and platforms, so application development with OpenShift. So a lot of what we've done is focus on DevOps life cycles and how that matters to the ops teams that have to support the developers. This is an extension of that, what we've done with MLOps, which is basically connecting the data science community with the application developers and the operations folks, so you actually do get a nice end-to-end workflow that can help reduce these friction points. And then we talk about software supply chain. Like, this has been in the news. I probably don't even need to mention this one anymore, but the security of your overall software supply chain is of huge value now, right? Like, nobody wants to be the one who introduced the bug that crashed the entire system or deleted your storage device or anything like that. So maintaining the provenance and confidence in how you're delivering your software is also a key consideration that extends to model development. And then the agility, right? Google had a statement, this was probably 4 or 5 years ago, where they talked about why they are the best in AI/ML. And it's debatable if they're the best in AI/ML, but I thought it was a really good statement. And they said it wasn't necessarily because they had the best data or the smartest people, but it was because they had the best processes that allowed them to run the most experiments. So when it comes to model development, there used to be this belief that the smartest people with the best data would produce the best model. That's actually not how it works, right? A lot of these models are iterative development. So you're trying something, you're testing it, you're trying another thing, testing it against it to see what the better result is. So your ability to quickly iterate on experiments, try new things, and be able to roll them out quickly, that's going to be your competitive advantage, right? Don't rely on one really smart person with a lot of really great data to get you that perfect model right out of the gate. It just doesn't happen. It's just how quickly you can do it. It's the old practice makes perfect. And then finally, the loss of confidence one. And this one I should probably put first, and it should probably get its own slide. The number one failure point I see when I talk to customers when it comes to the adoption of AI/ML is just the confidence of the company in what that model is telling it to do, right? And it doesn't take much for a company to lose confidence. If you have a model that's providing recommendations and customers get upset, it gives bad recommendations, or you can't justify why it's making the recommendation, people won't use it, right? Think of healthcare, right? Where for years we've had algorithms that could provide recommended diagnoses out to doctors. Doctors didn't understand where that was coming from, and so they generally didn't adopt them. In recent years, there's been a lot of emphasis put on making sure there was transparency into how that model was making the recommendation, the type of data that was used, the actual records that went into it, and then actually provided the recommendation. And you're starting to see more and more adoption of this. So that loss of confidence, like your ability to give that transparency to your end users is really going to be critical here to your success. Well, the great news for everyone here, and certainly for me as Red Hat, is AI/ML used to be a very proprietary-driven domain. Right? There used to be a handful of companies in the world that drove a lot of the innovation, provided a lot of the platforms, and had a lot of the expertise. That has changed dramatically over the last decade. And again, like 6 years ago, I would say every 6 months there was something new. The amount of innovation being driven around AI/ML in open source is immense. To the point now where, like, and you've seen it, like I'm sure a lot of folks here probably saw that Google paper, that proprietary vendors are very nervous about the level of complexity and advancement that's happening in the AI/ML world. And it's not just happening on the algorithm side anymore. It's happening on the platform side. It's doing all the things that we saw in open source for platforms and application development. It's 10x as efficient now on the AI/ML side. So there's thousands of communities. And we've even seen this in how we've been able to expand our OpenShift Data Science and OpenShift AI offering, because we bring in what's available in open source. And 6 years ago when we started, there were only so many things available. It was still a good amount of things, but now, like, the way we've been able to accelerate the product because of what's happening in open source is tremendous. And so if you're looking at how are you going to build a platform, if you're building your own today, which a lot of folks are, right? There were a lot of companies that had very smart ops teams that needed to serve their data science community, and they built their own platform. They brought in Jupyter notebooks. They brought in something for pipelines. Like, that's fantastic. I would ask yourself, like, is that your core business value, maintaining that open source platform? Because there are now vendors like Red Hat that can provide that for you. And so when we look across all those considerations and what Red Hat's doing to address these, this isn't something new for us, right? We didn't just hop on the bandwagon and say, like, AI/ML's cool, let's bring Steve in and figure out what we can do. Like, we have a legacy of being able to provide a lot of the core tenets of what it is we're talking about here. So when we talk about the complexity of deploying across multiple platforms and wanting consistency and security in the platform, that's what Red Hat Enterprise Linux has been doing for 30-some years. Right? And we've adapted it over those 30 years now to where we can have smaller footprints. We can have customizable footprints. So if you have a specialty need that only needs a small set of packages because you're deploying into an edge location, Enterprise Linux can give you that. On top of that, I'm sure everyone, it's OpenShift Commons. You've probably heard of this thing called Red Hat OpenShift. Great container orchestration platform, fantastic platform to provide for the scalability needed for training and serving these environments. It also lets you bring together those communities, right? We talked about the data science community, the application development community, and the ops community. There's a lot that Kubernetes can do to help with AI/ML. Again, 6 years ago, I used to have to give this presentation where I'd have a big definition up here of why containers could actually be used for AI/ML. Like, no one believed you could do such a heavy workload on containers. Now it's just understood that you can do this. So if you're still running VMs, and you're standing up separate VM environments for all of your different data science teams to run experiments, take a look at what Kubernetes can do for you, because it has far outpaced the innovation that can happen in your traditional VM environment. And then we've got Ansible. And you probably go, what does Ansible do? It's not a platform. When we talk about the orchestration of deployment, that whole continuous deployment process, Ansible plays a critical role in that, right? So when we talk about like Argo CD for managed deployments, Ansible for being able to orchestrate the deployment of your edge modules is critical, right? Again, factory floors, these things are spinning up, spinning down quite frequently. We look at a lot of disconnected environments. So you've probably seen some of our automotive examples. I don't know about you, but when I'm driving 65 down the road, I don't really want an over-the-air update applying to my car. I'd rather wait until maybe I've pulled in somewhere safe. So this type of disconnected environment and synchronization is something we're doing today with event-driven Ansible, right? So we can stage all of these updates, updated models for your vehicle for efficiency or anything like that. And then when there's an opportune moment, all these updates can roll out, and it's consistent, it's repeatable, and it's auditable. So it's a great platform for it. Oh, next one, okay. Oh, forward. No, backward. There we go, sorry. A lot of buttons this morning. It's early for me. So, and then finally, OpenShift Data Science and OpenShift AI, right? So you've probably heard these two terms. OpenShift AI is generally the umbrella family for everything we're doing around our AI platform. The reason we introduced it was 6 years ago when we first created what became the foundation for OpenShift Data Science. We had a pretty tight platform. It was focused on experimentation environments. So it had notebooks, handful of packages for model development and frameworks. But then I talked again about all that acceleration that's happened in AI and machine learning. And we've added a lot of stuff very, very quickly over the last couple years. So now we have model serving and monitoring. Again, like if you're looking at what it takes to serve models, common thing I run into customers, and someone's going to nod their head, so everyone like look for the person nodding their head when I say this. What they'll tell me is like, hey, we built a model, and it was really easy. We built it in PyTorch, and I stood it up in TorchServe. That wasn't hard. Like, why do I need your model serving? And you're right, like standing up a model in TorchServe, very easy, and it's a great framework. But when we get back to all of those considerations of how do you effectively scale that model across multiple nodes, how do we scale it with an environment, like that is a complexity that you don't want to build yourself in a TorchServe environment. And these are things we've managed within our model serving environment, which is based on Kserve. For those that are familiar with the Kubeflow project in Kserve, we're using model mesh, which can scale down to 0 and scale up to massive 10,000 node deployments across multiple clusters. So it's a very scalable environment. And then we've hooked into all the monitoring that you've come to know and love from OpenShift. Remember, we talk a lot about how do we monitor these things so that we can lifecycle them. We have relied heavily on all of Red Hat's innovation in this space. And so from an ops team perspective, this is really easy for you to manage. If you're already monitoring your OpenShift clusters, you have the ability to easily monitor all of your serving models that you're serving as well. Then we've recently introduced a lot for lifecycle management. This is about bringing those communities together. So we have introduced something called data science pipelines. It's based on Kubeflow pipelines, if anyone has played with those. It's basically a way for data scientists to build repeatable data science workflows. It's using their language, so they don't have to understand Tecton and all the nodes and how to do that. So, you know, train model, deploy model, that type of terminology. But under the covers, it's running Tecton. So again, for your OpenShift administrator, if you're administrating all the jobs across all of your clusters, to you, this just looks like another OpenShift job that's out there, right? But your data scientists are able to build it and maintain it themselves to help facilitate that handoff to your application development team. And this is all designed to be pluggable. So collaboration for us is a big thing. There's a lot of ecosystems out there today when you look at an MLOps platform that will take you from experimentation to serving to lifecycle, but you have to stay within their framework. We let you bring in tools from outside. So if you don't want to use our training environment, say you want to use something that's AutoML or something that isn't necessarily an open source today. That's great. Build a model on any tool you want, and you can bring it into our serving environment. By bringing it into our serving environment, then we can scale it for you, you can monitor it, and you can lifecycle it. If your data scientists are building pipelines on our platform, and they need to integrate with, say, a Microsoft Azure application development pipeline, that's great. All of these pipelines can be integrated and orchestrated together. So the key here is we have worked very closely and tightly with our ecosystem to make sure Red Hat is providing those core capabilities, but we know every customer, every industry, every vertical has its own set of demands and requirements. So we want to be able to bring in our ecosystem partners to provide for those specialty use cases. you're going to continue to see, and you should expect from Red Hat, that we're going to take open source innovation and move it into our environment very quickly. So as things start to advance, there is now some very advanced capabilities around AutoML happening in open source, in the Ray.io community and the Kubeflow community. You'll probably see that end up in our platform here pretty soon, right? So these capabilities are always going to continue to move. As they become adopted in open source, we're going to bring it in. And then for those that are maintaining their own platforms, so already talked about the security and challenges of the integration. The other thing is keeping up with the pace, right? One of the things, so our platform, we lifecycle every 3 weeks. Every 3 weeks, whether it's our cloud service or our disconnected environment or our managed on-prem, all of this updates every 3 weeks. It's the same software, so we're always bringing in that innovation. If there's CVE patches, fixes, capabilities, we're able to keep pace with what's happening in open source very quickly. Okay, so hopefully I've convinced you, but if not, there's a lot you can expect around open source and AI/ML. And this is something, again, if it's with Red Hat, I would love for it to be with Red Hat, but either way, your companies, your enterprises, you're going to be adopting AI/ML, and I guarantee you, you're going to be using something from open source. So please talk to us about it, because it's something we have thought deeply about. We do have a tremendous vendor landscape and set of partnerships here. So a lot of them are out here today that do add very specialty capabilities, right? So if you need GPU slicing or more advanced generative AI UIs, we have those sets of partners that can plug into us. So you're going to hear a couple of customers come up and talk about how they are using this platform and things they're experiencing this week. You're going to hear others from Red Hat talk about innovation that's happening across the Red Hat portfolio around this space. So pay a lot of attention. If you've got questions, I'll be around. Super excited everyone is here. So thank you, and I hope you have a great rest of the conference.